Hello everyone, in this video we are going to work on some further examples on quadratic inequalities. The first example, solve the inequality x over x minus 1 greater or equal to 3. Now, as I told you in dealing with quadratic or in generally these inequalities, which are a combination of different expressions, you first need to standardize it. So transfer 3 to the left hand side. Now it will be x over x minus 1 minus 3 greater or equal to 0, because at the end we are going to transfer whatever information we have into the change of sign table. What is change of sign? Change of sign just says greater or equal to 0, less or equal to 0. It doesn't give you any further information about the value like greater than 3, less than 2, these types of inequalities. That's why we have to have just 0 on the other side, means either positive or negative. Now, next step is to take common denominator, to make it one fraction. X over x minus 1, it will be minus, I multiply it is 3 over 1 times x minus 1 times x minus 1 greater or equal to 0. It will be x over x minus 1. Let me write it as a single fraction here. It will be x minus 1 as our common denominator. It will be minus 3x, be careful, negative, should be multiplied by both of them. Minus 3x plus 3 greater or equal to 0. So it simplifies to x minus 3x will be negative 2x plus 3 over x minus 1 greater or equal to 0. Now the difference between this case and the previous cases that you have seen is that here you have two expressions for which you need to have a change of sign table. So I separately solve these equations. The first one, 2x plus 3 is equal to 0, giving you an answer of x is equal to minus 3 over negative 2, which is 3 over 2. And the second one, x minus 1 is equal to 0, giving you an answer of 1. Now I construct the change of sign table here. Here the first row x, but here you don't have just one single expression. We have two expressions for which I will have one individual and separate row. Minus 2x plus 3 is the first row. The second row is x minus 1. And here, and here I will put the whole expression, because we are going to decide about the whole expression, I mean as a fraction, which is minus 2x plus 3 over x minus 1. Now I write roots in order. The first one is 1. The second one is 3 over 2. Here 3 over 2 makes this expression 0, so that's why I put here 0. 1 makes this expression 0, and I put a 0 here. Now just here 3 over 2 makes the numerator, which is minus 2x plus 3, 0. So if numerator is 0, so the fraction would be 0. So I put a 0 here. But 1 cannot be placed in the denominator, because the denominator of a fraction cannot be 0. That's why I shade it somehow to show that 1 is not allowed to be put in a denominator. Now let's decide about signs. It's a straight line. It's a straight line, and the gradient is negative 2. So it has downward grades. For example, downward gradient. So it's, for example, 3 over 2. So before the root, it is positive. Root is here. Before the root is positive because it has downward trend. It is the slope, the gradient is negative. So it means that it's going down. So before the root positive, after the root negative. Even if you know you cannot use this method, if you forget it, you forget these points, you cannot implement them, you can just put some numbers. For example, put a number before 3 over 2. for example 1. If you put 1 here, it would be minus 2 plus 3, which is 1, which is positive. So it means that before this number, it takes positive values. Now put a number after 3 over 2. For example, 2. 2 times negative 2 will be negative 4, plus 3 negative 1, so it takes negative values. The same here. This line has a positive gradient, so it goes up. Before the root is negative, root is here, before is negative, after is positive. It's not like, quadratic inequalities for which we have two roots between the roots. It has just one root because they are linear. Now, it's a fraction. To decide about fractions, you know that sign of numerator and denominator are multiplied by each other. So plus times positive over negative will be negative, positive over positive will be positive, negative over positive is again negative. Now we want this expression to be greater or equal to 0. So this interval is our required interval. So it means that x must be more than 1. Be careful, it is not included here because 1 cannot be put in the denominator. That's why it's excluded. And less or equal to 3 over 2. Between these two numbers, 1 and 3 over 2, it gives you positive values, the whole expression. Now, let's see one more example. Example 2. Solve x over x minus 1 over x plus 1 greater than x. Now, I first transfer to the other side. All it will be x squared minus x over x plus 1 minus x is greater than 0. So I take common denominator, it will be x plus 1, x squared minus x. If you take common denominator, it will be minus x squared minus x greater than 0. These two cancel out each other, so at the end will be negative 2x over x plus 1 greater than 0. Now again, you have two expressions for which you need to have a change of sign table, numerator and denominator separately. So minus 2x is equal to 0, x will be 0, and x plus 1 is equal to 0, giving you an answer of negative 1. Now I go for change of sign table. First row is numerator, second row denominator, and overall the whole fraction, it will be minus 2x. It was minus 2x over x plus 1. Now I put roots here in order. The first root was negative 1, then 0. 0 is the root of this expression. I put 0 here. Negative 1, the root of this expression. Here at negative 1, because it's denominator, it will be undefined. And at 0, because numerator is 0, so it makes the fraction 0. So I put a 0 here. Now, so it's again a straight line having a negative gradient. So it has downward trend. So before the root will be positive, root is here, positive, then negative. Again, it's a straight line with positive gradient. So before the root, which is here, negative, then positive. Now we should compile our signs. Positive over negative will be negative, positive over positive, positive, negative over positive, again negative. We want overall our answer in a standard inequality, which is here, sorry, to be positive. So x should be less than 0 and greater than negative 1, because it says greater than 0, equal is not included here. That's why 0 is excluded here, because we don't want this expression to be equal to 0, just strictly greater than 0. It was the second example. Now let's see one more case. Now solve x squared minus 2x minus 15 over x minus 2 greater or equal to 0. Now this question is already in the standard form. I just find the roots for denominator and numerator separately. is equal to 0, it will be x minus 5 times x plus 3 is equal to 0, giving you an answer of 5 and negative 3. Now, I go for denominator as well. X minus 2 is equal to 0. X is 2. Now, change of sign table for here x. The first, it is your numerator, x squared minus 2x minus 15. The denominator, which is x minus 2, a linear, it's combination of quadratic and linear both. Then x squared minus 2x minus 15 over, it seems like 1, I make it 2 over x minus 2. Now we have 3 roots here, so I construct 3 lines here. The roots is written in order, first negative 3, then 2, then 5. Now here roots of these quadratic are minus 3 and 5, so I make 0 here, 0. The root of the denominator x minus 2 is 2 here, so I make it 0. So it's a quadratic expression. So we know that it bends upwards because coefficient of x squared is 1, so it bends upwards. So before the first root, it takes positive values. Between the roots, ignore 2 here, ignore 2 here. Roots are negative 3 and 5. So between negative 3 and 5, like negative 3 is here, 5 is here. It takes, negative values. So it's here. After 5, it goes up, positive values. Now, this is a straight line with a positive gradient. Before the root, it takes negative. Root is here, no matter how many columns you have. Before the root, negative. After the root, positive. Now, here, as denominator cannot be 0, I exclude this number here. Now, here positive over negative, negative, negative over negative, positive, negative over positive, negative, positive over positive, positive. Now we should decide the required region. It says overall it should be greater or equal to 0. So there are 2 answers here. Once here, once here. The first interval is x less than 2, more or equal to negative 3, or x is greater or equal to 5. So these are the 2 intervals which satisfy this inequality. Thanks for watching this video.